Hello, my name is Peter Kriemadis, and I am a graduate student at McMaster University in the Engineering Physics Department. Today, I will be presenting the work that my supervisor, Dr. Baus, and I have compiled in our paper, Preliminary Work in the Verification of Reactor Kinetics Parameters of Small Modular Reactors through Subcritical Test Assemblies. First, let's explore the background for this problem. Many new SMR designs are novel, and several new technologies or methods are used. These technologies and methods tend to be unproven, making commercialization difficult. Demonstration reactors are necessary for qualifying these new SMRs, and due to their unproven nature, are also incredibly difficult to build. The kinetics parameters of a nuclear reactor, namely the reactor temperature coefficient, alpha, the delayed neutron fraction, beta, and the prompt mean generation time, lambda, are essential to ensuring safe design and operation. Currently, the only way of validating these kinetics parameters is in a critical assembly, offering a unique problem with the creation of a demonstration reactor. An experiment to determine the kinetics parameters external to a demonstration reactor would be valuable. A subcritical assembly may be designed to have similar kinetics parameters to a critical one. A subcritical assembly would be inherently stable and could be designed to have no cooling requirements, both leading to relatively low-cost experiments. Unfortunately, under Canadian regulation, a subcritical assembly is subject to the same licensing requirements as a critical reactor, both being Class 1A facilities. However, this may make the experiment more attractive to organizations which already operate Class 1A facilities. Regulatory Document 367 and Reg Doc 2.5.2 give some precedent to needing to know the kinetics parameters to safely design and operate a reactor. The DIS 1604 consultation defines the problem of making a demonstration reactor as one which requires extra safety measures. Experimental data from a subcritical assembly may not only expedite the creation of a demonstration reactor, but reduce the requirement for extra safety measures. Determination of the kinetics parameters in a subcritical assembly is non-trivial. Making the assumption that a calibrated rod cannot be used to determine the reactivity state of a subcritical core, reactivity determination is difficult. Only reactivity in dollars may be found directly, where a delayed neutron fraction is needed to determine reactivity. Reactivity can also be found in the form of the prompt decay constant, but this would require delayed neutron fraction and prompt mean generation time. Using a difference of the prompt decay constant between two reactivity states, the prompt mean generation time may be found. However, these methods are usually applied in isolation and heavily rely on simulation results to solve for the reactor kinetics parameters. The delayed neutron fraction is necessary to determine the other kinetics parameters of a subcritical assembly. However, this will require the application of more sophisticated methods and is subject to further review. The kinetics parameters of a subcritical assembly can be designed to approximate those of a critical one. Ideally, the subcritical assembly will be similar in geometry and material composition to the core it is representing. However, geometry and/or material composition must be fundamentally altered to generate a subcritical state. Satisfying the sensitivity of detectors and ensuring the safety of a subcritical assembly will be a design challenge. Also, filtering of source neutrons may be required, as fission-borne neutrons hold the kinetics information. Experiment neutronics design is non-trivial. A subcritical assembly may be a productive experiment to validate the kinetics parameters of novel SMR designs, where this may expedite and simplify demonstration reactor licensing. There is some basis for this idea within Canadian regulation, but unfortunately, a subcritical assembly is subject to the same licensing requirements as critical reactors. Measuring the kinetics parameters in a subcritical assembly is highly non-trivial. A method to determine the delayed neutron fraction is necessary and requires further investigation. The electronics design of the experiment itself will be a non-trivial balancing act of safety and detector sensitivity. Thank you for listening to our presentation. If you have any questions, please direct them to me, Peter Kriemadis, at creamadp@mcmaster.ca. Thank you.